Hi students, welcome to the science class. In last session we discussed about the expression for three resistors when they are connected in series and also when they are connected in parallel. What are the expressions sir? So when three resistors R1, R2, R3 when they are connected in series, the equivalent resistance of a three resistor is equal to, that is Rs is equal to R1 plus R2 plus R3. This is the expression for the three resistors when they are connected in series. And second one, when the three resistor R1, R2, R3 when they are connected in parallel, what is the equivalent resistance? That is 1 divided by Rp is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. This is the another one expression which we are going to derive in last class. So now we are going to discuss some problems on these two expressions. These are the most important and very easiest problems comes in your examination for 3 to 4 marks. So you have to concentrate on these examples. Now consider one example. First example, an electric lamp whose resistance is 20 ohms and a conductor of 4 ohm are connected to a 6 volts battery. Calculate the total resistance of the circuit B, current through the circuit C, the potential difference across the electric lamp and conductor. See, once again you have to read the given question. An electric lamp whose resistance is 20 ohm and a conductor of 4 ohm are connected to a 6 volt battery. Calculate A, the total resistance of the circuit, B, the current through the circuit, and C, the potential difference across the electric lamp and conductor. When they are going to give such a type of examples, you have to draw a simple circuit diagram based on the given data. What they are given here? A conductor, a simple conductor, a 6 volt battery and a bulb. So you have to draw a simple circuit. See here. This is the conductor. I am taking here some resistance because they are given the resistance of the conductor, that is 4 ohm. That's why I am taking one resistor here, and this will be connected to a one lamp. Okay, this is the current I. So what is the resistance What is the resistance of the conductor? That is 4 ohm. What is the resistance of the bulb? That is 20 ohm. And what is the potential difference? That is, what is the potential difference of the battery? That is 6 volt. See what they are asked. Solution. First one, A, the total resistance of the circuit. A, the total resistance of the circuit. Total resistance of the circuit. R is equal to, here the resistance of the conductor and the resistance of the bulb, they are in a series connection. Therefore, the resistance R is equal to R1 plus R2. Here R1 is equal to 4 ohm and R2 is equal to 20 ohm. That is, total resistance of the circuit R is equal to 24 ohms. Then second one. Why I am considering R is equal to R1 plus R2? Because we know that when the resistors are connected in series, the equivalent resistance of that series is Rs is equal to R1 plus R2 plus R3. But here only two resistors. One resistor, it is nothing but a conductor, another one is a given bulb. They are in a series connection. Therefore, the total resistance R is equal to R1 plus R2. That is, R is equal to R1 plus R2. That is 4 ohm plus 20 ohm. That is, R is equal to 24 ohm. And second one is what they are asked, current. The total current. The total current flowing through the circuit. The current through the circuit. I is equal to V by R. We know the formula. I is equal to V by R. Here the potential difference given here. What is the potential difference? That is 6 volt. Then divided by what is the total resistance? R is equal to, that is 24. R is equal to 24 ohm. That is equal to, I is equal to 6 ones are 6 fours are. I is equal to 0.25 amps. Isn't it? Because the total resistance of the circuit is 24 ohm and the potential difference, that is potential difference of the battery, that is 6 volts. Therefore, the total current through the circuit I is equal to V divided by R, that is equal to V is equal to 6 volts and R is equal to 24 ohms. That's we get I is equal to 0.25 ampere. And third one, what is the third question? What they are asked? Third one is the third question, the potential difference across the electric lamp. PD across electric lamp. PD across electric lamp. P1 is equal to, here they are asking PD across electric lamp and also across the conductor. That is equal to, V is equal to, here we know that I is equal to V by R. It implies V is equal to I into R. We know the formula, electric current I is equal to V by R. It implies V is equal to, this R will be comes here, that is in the form of multiplication, V is equal to I into R. Therefore, the potential difference across the electric lamp 20 ohms, that is equal to V1 is equal to what is the R value? Total resistance. V1 is, here is the resistance of the lamp is 20 ohms into current is 0.25. that is V1 is equal to 20 into 0.25, we get 5 volts. And under one PD across conductor is equal to V2 is equal to again the resistance of the conductor is 4 ohm into the current I is equal to 0.25, that is V2 is equal to how much we get, that is 1 volt. These are the simple problems comes in your examination for 3 to 4 marks questions. Once again I am repeating here, when they are give these type of examples, you are going to draw some basic diagram, some basic circuit diagram. On the basis you may get the easily the solution. Have got understood? So you have to practice these type of problems. It may helpful for your examination. Now I am considering another one example. Calculate the total resistance of the given circuit that is yes, they are given here one circuit, and in the circuit they are going to give values of the resistance. That is, here I am considering this one is a R1, that is the resistance of the R1 is 20 ohms. Second one R2, the resistance of the R2 is 20 ohms. Then R3, the resistance of the R3 is 20 ohms. And next this one is R4, the resistance of the R4 is 10 ohm. R5, the resistance of the R5 is also 10 ohm. Next this is R6, the resistance of the R6 is 30 ohm. See, when they are going to give these type of problems, you have to clearly observe the given picture. You may are going to divide this given diagram as on the basis of parallel resistors and the series resistors. First you may are going to calculate the series resistance. After that you are going to draw another one circuit diagram, and next you are going to calculate side by side. If it is a parallel, then you are going to calculate the parallel resistance. If it is a series, then you are going to calculate series resistance. See the solution now, how we are going to calculate here. Solution, see the given circuit diagram. R1, R2, R3, these three are in series. First, these three are in series connection because they are in end-to-end connection. So we are going to calculate first here the series resistance Rs. First, Rs is equal to R1 plus R2 plus R3. Why? Because they are in series. R1, what is the value of R1, R2, R3 here? That is 20 ohms. 20 plus 20 plus 20. That is Rs is equal to, that is Rs1 is equal to 60 ohms. Okay, now I am again consider here R4 and R5. These are also in series connection. So we are going to calculate again we are going to calculate they are in series. So we are going to calculate series resistance, that is second one Rs2 is equal to R4 plus R5. What is the value of R4 here? That is 10 ohm plus 10 ohm. 10 plus 10. That is Rs2 is equal to 20 ohms. Again here R6 is 30 ohm. There is no series resistors connected to another one resistor here. Now we are going to change the circuit diagram because these three resistors are replaced by a equivalent resistance 60 ohm and these two resistors are replaced by a equivalent resistance 20 ohm. Then the circuit diagram becomes what happens here? This is Rs1, Rs2, this is R6. See what happens here, what we are going to change here, because these R1, R2, R3 are connected in a series combination. We may replace these three resistors with the equivalent resistance Rs1 is, that is 60 ohms. Then again R4 and R5 in the series connection, we are going to replace these two resistors with the equivalent resistance Rs2, that is 20 ohms. Then the value of R6 is given here, that is 30 ohm. See here, see the diagram. Rs1, Rs2, R6, these are in a parallel connection. They are in the parallel connection. Now we are going to calculate the equivalent resistance, that is 1 divided by Rp is equal to 1 divided by Rs1 plus 1 divided by Rs2 plus 1 divided by R6. That is equal to 1 divided by Rs1 value is 60 ohms plus 1 divided by Rs2 value is 20 ohms plus 1 divided by 30 ohm. Take the LCM here, that is 60. We are going to multiply here 3 because 20 into 3 is equal to 60. Here 2, that is here 1 into 1. 1 plus 3 into 1, that is 3 plus 2 into 1, 2. That is equal to 1 plus 3, 4. 4 plus 2 is equal to 6. 6 divided by 60. 6 ones are 6 tens are. That is equal to 1 divided by Rp is equal to 1 divided by 10. It implies Rp or R is equal to 10 ohms. This is the total resistance of the circuit. R is equal to 10 ohm is the total resistance of the circuit. Therefore, the total resistance of given circuit is 10 ohms. See, these are the very simple problems based on the circuit diagrams. You may practice more and more because these are very simple problems. All the data will be given in the circuit only. It is very easiest one. Once again I am repeating here, when they are going to give these type of circuit diagrams, first you are going to calculate the series connections or in the parallel connections. Some of the diagrams are mixed. For in that, some of the diagrams, first you are going to calculate the parallel because some of the resistors are connected in parallel. After onwards, you are going to calculate in series. So first you have to understand which type of circuit here given. Here it is the easiest way to calculate here is first we are going to convert these R1, R2, R3. These are in a series connection. We are going to calculate the equivalent resistance of these three resistors. Again R4 and R5 are here. They are in the series connection, and also we are going to calculate here the equivalent resistance of R4 and R5. We get RS1 here and we get RS2 here because the equivalent resistance of these three resistors we get, and also equivalent resistance of these two resistors we get. We are going to replace all three resistors with the RS1 and these two resistors with the RS2. We get this circuit, and when considering this circuit, all the three resistors are in a parallel connection. Therefore, by the parallel resistance rule, that is 1 divided by Rp is equal to, when the resistors are connected in parallel, the equivalent resistance of that resistors is, that is 1 divided by Rp is equal to 1 divided by here RS1 1 divided plus 1 divided by RS2 plus 1 divided by R6, that is 30 ohms. By substituting the values of RS1, RS2 and R6, we get the total resistance of the circuit is 10 ohms. Is it clear? Yes, I feel it's clear. So these type of examples will may ask to your examination for 4 marks question. These are the very simple problems. Now I am consider another one example. A similar another one example. Third example. In figure R1 is equal to 10 ohm, R2 is equal to 40 ohm, R2 is equal to 40 ohm, R3 is equal to 30 ohm, R3 is equal to 30 ohm, R4 is equal to 20 ohm, R4 is equal to 20 ohm, R5 is equal to 60 ohms, and a 12 volt battery is connected. 12 volt battery is connected. A 12 volt battery is connected to the arrangement. Calculate the total resistance in the circuit. And B, the total current flowing in the circuit. And the circuit is here, and the given circuit is. This is the battery. This is R1, R2, R3, R4 and R5. So we have to calculate the total resistance of this circuit and also the total current flowing through this circuit. The value of R1 here given is the value of R1, that is 10 ohm. We have to write down here. R2, the value of R2 is 40 ohms. Value of the next value of R3, that is 30 ohm. Next, the value of R4, that is 20 ohms. Value of R6, that is 60 ohm. See, when we are going to calculate the total resistance, see, consider this circuit diagram. R1 and R2 are parallel here, and R3, R4 and R5 are parallel here. First we are going to calculate, we should calculate R1 and R2, the parallel resistance. R1 divided by Rp is equal to 1 divided by R1 plus 1 divided by R2. Why? Because R1 and R2 are in the parallel connection. Solution: 1 divided by Rp1 is equal to 1 divided by R1 plus 1 divided by R2. That is equal to 1 divided by the value of R1 here is 10 ohms plus 1 divided by R2, that is the value of 40. That is we get, that is equal to here the LCM is 40. We are going to multiply here 4 here into 1, that is equal to 4 into 1 is equal to 4 plus 1 into 1 is equal to 1. 4 plus 1, that is equal to 5 divided by 40. 5 ones are 5 8s are, that is equal to 1 divided by 8, that is Rp1 is equal to 8. Next we are going to calculate 1 divided by Rp2 here, that is R3, R4 and R5 are in the parallel connection. We are going to calculate separately, not continuously, because they are in a separate connection. These R1, R2, R3 are in series connection with R3, R4, R5. We should calculate R1 and R2 separately and R3, R4 and R5 are separately. They are not continuously parallel. They are R1 and R2, these are parallel, and this connection will be series with the parallel connection of 3 resistors R3, R4 and R5. Have got it? So now we are calculate 1 divided by Rp2, that is equal to 1 divided by R3 plus 1 divided by R4 plus 1 divided by R5, that is equal to values of Rp2, that is values of R3, 30 plus 1 divided by R4, that is 20 plus 1 divided by R5, that is 60. So again here the LCM is 60. LCM is 60. Here we multiply 30 into 2, that is equal to 60, that is 1 into 2 plus here we multiply 3, 20 into 3 is equal to 60, that is 1 into 3 is equal to 3, plus here 60 is there, therefore we are going to multiply into 1, that is equal to 1. Here we get 2 plus 3 is equal to 5, 5 plus 1 is equal to 6, 6 divided by 60, 6 1s are 6 10s are, that is 1 divided by Rp2 is equal to 1 divided by 10. It implies Rp2 is equal to 10 ohms. But consider the diagram. These two parallel resistors are in series connection with these 3 parallel resistors. So we are going to calculate the equivalent resistance of the circuit. The total equivalent resistance of the circuit, it is nothing but the total resistance of this circuit. How we are going to calculate total resistance here? Now we are going to remove, now we are going to replace these 2 resistors by equivalent resistance 8 ohms and these 2 resistors by equivalent resistance Rp2. Then the connection, see here how what happens here. What is the value of Rp1 here? RP1 is equal to 8 and RP2 is equal to 10. And now I am replacing the equivalent resistance. Now I am replacing these two resistors by equivalent resistance. RP1 is equal to 8 ohms and these three resistors by equivalent resistor RP2. See that circuit diagram. The RP1 is in series with RP2. Therefore, the equivalent resistance R is equal to RP1 plus RP2. That is R is equal to, why we are calculating here in a series connection? Because these two are in a series. So total resistance R of the circuit R is equal to RP1. The value of RP1 is 8 ohms plus RP2, that is 10 ohms. Therefore R is equal to 18 ohms. This is the equivalent resistance of the circuit. I got understood. And the second question is the total current flowing through the circuit. The total current the total current I is equal to, we know the formula, I is equal to V divided by R. Here the value of V they are given here, 12 volt battery, that is 12 divided by the total resistance here is 18. Therefore the total current flowing through the circuit, I is equal to 0.67 ohms, ampere. I is equal to 0.67 ampere. By calculating the total resistance of the circuit, they give the potential difference of the battery. We are going to easily calculate the total current flowing through the circuit. That is by using the formula I is equal to V divided by R. Here V is the total potential difference of the battery, that is 12 volts, and R is the total resistance of the circuit, that is 18 ohm. We get the total current flowing through the circuit is 0.67 ampere. You should write the SI unit. If you miss the SI unit, you are going to miss 1 marks in your examination. Be careful. Now I am considering another one example on this base. You have to practice these type of problems in your home. Some of the examples are given in your exercise. You have to practice it. I will give the solutions, but before that you have to practice. Fourth one. Calculate the total resistance. Of the given circuit. Calculate the total resistance of the given circuit. See the circuit here. See the value of the resistors here, that is 10 ohm. I am considering here R1, R2, that is 20 ohms. I am considering here as R2. This is R3. the resistance of the R3 is 20 ohms, and here R4, the resistance of the R4 is 10 ohms, and R5, the resistance of the R5 is also 10 ohm, and R6, the resistance of the R6 also 10 ohm. Then R7, the resistance of the R7 is 30 ohms. You have to calculate the total resistance of this circuit. Consider here, so when you are going to see the circuit, these two are in parallel and these three are in parallel, and these 3 and these 2 are in series connection with R1 and R7. So first we should consider, we have to calculate the parallel resistance of R2 and R3, and we have to replace this R2 and R3 by the equivalent resistance, and next we are going to calculate R4, R5 and R6 of the parallel resistance. Then we are going to replace by the equivalent resistance by 3 resistors. Then we get here RP1 and RP2. All the 4 resistors are in series. Next we are going to calculate the equivalent resistance RS by RS is equal to R1, RP1, RP2 plus R7. Consider here first one, that is RP1. 1 divided by RP1 is equal to, because these R2 and R3 are in parallel connection, therefore 1 divided by RP1 is equal to 1 divided by R2 plus 1 divided by R3, that is equal to the value of R2 here 20 ohm and 20 plus R3 also 20, that is equal to 20 here 1 plus 1, that is equal to 2 by 20, that is equal to 1 divided by 10. 2 ones are 2 tens are. 1 divided by RP1 is equal to 1 divided by 10. It implies RP1 is equal to 10 ohms. Next, second step, that is RP2. 1 divided by RP2. In RP2 we are going to consider the resistors R4, R5 and R6, because these three resistors are in a parallel connection. Therefore 1 divided by R3 plus 1 divided by R4 plus 1 divided by R6, that is equal to the values of R3, R4 and R5, R6 are 10 ohms, that is 4, 5 and 6. R4, R5 and R6. This is R2 and R3. Yes, 1 divided by 10 ohm plus 1 divided by 10 ohm plus 1 divided by 10 ohm. Here the LCM is 10. We are multiplying here only 1, because here in the base we get only 10. So into 1 into 1 into 1, that we get 1 plus 1 plus 1, that is equal to 3 divided by 10, that is equal to 1 divided by RP2 is equal to 3 ones are 3 threes are 9.1 remaining becomes 10, again 3.3, that is 1 divided by 3.3, that is RP2 is equal to 3.3 ohms. Next, here now we are going to replace R2 and R3 by equivalent resistance 10 ohms, and also R4, R5 and R6 by equivalent resistance 3.3 ohm. Then the circuit diagram becomes the circuit diagram will be converted into this type, because these all parallel resistors should be replaced by equivalent resistance. I am considering here R1, the value of R1 is 10 ohm, and this is RP1, the equivalent resistance of R2 and R3, that is RP1 is equal to 10 ohm, and this is RP2, that is, what is RP2? The equivalent resistance of R4, R5 and R6, that is 3.3 ohm, And last one is it is given R7. The value of R7 is 30 ohm. Now the total resistance R is equal to R1 plus RP1 plus RP2 plus R7. Why? Because all the resistors are in the series. Therefore, R1 is 10 ohm plus RP1 is also 10 ohm, RP2 is 3.3 ohm and R7 is 30. That is equal to 10 plus 10 20, 20 plus 30 50, 50 plus 3.3, that is 53.3 ohms. This is the total resistance of the circuit. This is the total resistance of the circuit. You should carefully see the given diagram. First, what we are going to make, whether we are going to calculate first series resistance or whether we are going to calculate first parallel resistance based on the circuit diagram. These type of examples should be asked in your examination for 4 marks. So you have to concentrate on the diagrams and also on the examples. Today's sessions we discussed some of the problems on parallel resistance and also on the series resistance. These type of examples may ask in your examination for 4 marks question. These are very simple problems. You may practice these problems. Okay. In the next session we are going to continue the chapter electricity, that is heating effect of electricity, in the next session. Thank you.